This is TWIS. This Week in Science episode number 1043, recorded on Wednesday, January 14th, 2026. The uncertainty of science. And everything. Hey, everyone, I'm Dr. Kiki, and tonight we will fill your head with red hair, queen bees, and problems with quality control. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience. Disclaimer, disclaimer, disclaimer. I'm trying to think of something optimistic to say to start the show with a big hooray, but the state of things as they are, it's getting harder to remember that there is still more to discover, that people will always seek to learn more, to be curious, ask questions that will be answers tomorrow. Though today might be dark, we can look to the light and fill ourselves with knowledge tonight here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
And a good science to you too, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again with another week of stories to discuss, another week of experience under our belts in this mortal coil. Oh boy, what a week it was. There's some fun science out there. So let's take this tight 90 to lean back, talk curiously, and maybe a little snarkily at times, but to discuss and think about things happening in the world. I have stories about hot waters, a debate about plastic, electric vehicles in Africa, red hair benefits, and some brain news. What's in the animal corner, Blair?
Nice. Do I even remember? I have the Atacama Desert. I have bee tongues. I have AI. Is it good for animals? We'll find out. And then also glow in the dark deer scrapings.
Wait, what? What was
glow
that?
in the dark deer scrapings.
Okay, I can't wait to see that one.
Yeah. That's usually I have spares, just like I have bears, I have bees, I have the desert. No, complicated tonight. We'll get into it.
Well, because life is complicated. We can go there. We can handle the complexity, the uncertainty. We'll take it where it goes.
That's right.
Yeah. Everybody ready for this? If you have not yet done so, you can subscribe to This Week in Science wherever you are watching right now or listening. We are a podcast. We're also live streamed weekly, Wednesdays, 8 p.m. Pacific time on Facebook, Twitch, and YouTube. And if you're interested in more information about the show, you can head over to twis.org for things like our Patreon, our Zazzle store, and show notes for every episode. It's all good stuff over there and here. And now it's time for the science. You ready?
I'm ready.
Woot. Let's do it. Okay, let's dive in first into some hot waters.
Hot water, like, so usually bad, but if you're making tea, good.
I know. For tea, it's wonderful. If you're using it as, like a, I don't know, the water you pour over the rocks in a sauna, that's nice. But when it's your oceans,
oh yeah, bad.
It's bad. We don't like it so much. No. So this week, published January 9th, Advances in Atmospheric Sciences, there was a paper titled, what? Ocean heat content sets another record in 2025.
Boo.
Yeah. So What's interesting, though, is heat content versus temperature versus what is actually happening in the ocean. So surface ocean temperature is important for how our atmospheric conditions develop. So surface water temperature changes where they get hotter or colder. We know, like in hurricane season in the Pacific, in the Atlantic, as the around the equator, we get hotter water, and the surface temperatures build during those hotter times of the season. Suddenly you have greater energy at that water air interface, and so you have larger storms, bigger hurricanes, that can be a big problem as they come in to the Caribbean or the East Coast, right? This happens all around the world in the different oceans that are actually connected. But the oceans themselves are a heat sink. They are capable of absorbing heat from the atmosphere. So the atmosphere itself is not super, super hot, and we're not all just being air fried on top of the land masses. The oceans are not just a carbon sink, they are a heat sink as well. And Blair, you've talked about this so many times on the show throughout the years, so you know a lot about this, but I'm just going to keep going with this story, and then I'd love to hear what you have to say about it. But 2025 has been named one of the hottest years on record. Additionally, this study in Advances in Atmospheric Sciences found that the ocean, which means all the oceans, gained 23 zettajoules of energy.
What even is zeta? How many zeros is that?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 23 times 10 to the 21st. According to a press release, as they've, tried to make this something we can understand, that's 37 years of total global primary energy use at 2023 levels, which were 620 exajoules per year.
What?
Basically,
23 times what we did in 2023?
37 times what we did in 2023. Okay. How much energy we used.
We used 37 times more energy in 2020. Oh, okay.
No. Okay. We did not use. This is, so the ocean absorbed. So they're trying to make it something
got it.
We can understand.
Got it. We're doing some social math. I get it. Okay.
Yeah.
So it's basically what, but the ocean normally absorbs in a year a lot of energy.
A lot, yes.
So the question
normal, but
is it how much more than what did it absorb last year? I guess that's what I'm getting is those are equating two things that aren't really related. That's like saying it's like putting 37 microwaves in a pool. I don't understand what it's kind of unrelated. I don't.
Yeah, well, it's like so that measure was simply trying to say, hey, the amount of energy that went into the ocean in the form of heat that's being stored in the ocean is the amount of energy that is 37 years worth of our global energy use.
Right.
So sea surface temperatures they're the warmest year, the third warmest year on record in the instrumental record. So the sea surface temperatures, and the temperatures remained about 0.5 degree Celsius, that's about 1 degree Fahrenheit, above the 1981 to 2010 average. Regardless, this contributed to, because it was hotter sea surface temperatures, this contributed to things like drought in the Middle East, flooding in Mexico and the Pacific Northwest, all our atmospheric rivers, woo! Mm-hmm. The warm temperatures, we're in the 50s and 60s, in Portland, Oregon right now. It should be cold and it's foggy, but it's not rainy. where like we had some major atmospheric rivers, but they were warm and the snow hasn't come. We are not getting the snowpack. We are pushing forward 2025 to 2026 for some serious drought conditions for the next year or so. So anyway, the earth and the oceans are going to keep absorbing heat. But as that happens, Blair, you know, also we have thermal expansion so that low-lying areas are going to be impacted by rising sea levels. And when things like hurricanes or typhoons come through, that water is going to be pushed onto a larger area of land by more violent winds, and probably more water will be as well. There is a special collection of articles that's on ocean heat content changes that's been organized by Advances in Atmospheric Sciences. But basically, like,
yeah. So
I mean,
yes,
before when in the late fall, the meteorologists were trying to forecast what our winter was going to be like. They said, okay, December will be cold. January is where you'll see like more precipitation and colder temperatures. And they did not have this inversion in their plans. Like this was not something that was on their radar. Haha, pun not intended.
You can intend it. It's okay.
Yeah. And so it's really interesting because we're probably going to end up on, who knows, but we may end up with a cold, rainy, snowy February. But I'm just talking from where we are. But what's happening right now is, after reading this paper and reading about what's happened with 2025 and the ocean temperatures and heat, I'm actually not surprised. Like it all
I think
kind of falls in line. Yeah.
The thing that's concerning to me where I live is that my walkways around my house covered in pollen. It's
already
January. So that's problematic for a couple of things. For one, very problematic for my husband, who is so allergic. Poor guy.
Allergies.
Supposed to get, a break in the winter months. No. But really, ecologically, it's a huge problem because it throws pollination cycles out of sync. If you depend on invertebrates to pollinate, but pollen is released when it is still cold in the morning, those animals are still in torpor, or they are elsewhere, or they are not the right age, or any number of things. That means your pollinating animals are not going to do their job. But what's even worse is, even if you successfully pollinate, like if you're a broadcast pollinator and you're just pollinating by the wind and you pollinate a tree, you're a tree, you release your pollen, you pollinate a female tree 100 yards away, right? And then that tree releases seeds that are now fertilized. And then you get that cold spell that Kiki was talking about in February. Those seeds are toast. So that is the thing that's really problematic about this sort of thing, is that when you throw seasonal variations out of whack like this, there are huge cascades that come as a result that can cause huge ecological failures. And normally, when these changes take place over tens of thousands, hundreds of thousands of years, plants and animals can adjust because it is gradual. But of course, the issue here with climate change is, and always has been, the rate of change. It is the fact that these things are happening so fast that they are completely unprecedented in changing this quickly. So it's really that's the big concern. And with the ocean, the thing about the ocean is, like, it's very easy to think about, okay, rising ocean temperatures, that's going to hurt animals in the ocean, or plants in the ocean, or it's going to affect ocean currents, right? But the ocean is like the climate's heart. And so it actually works to pump hot and cold water, which in turn influences hot and cold air on the surface. And so when you disrupt ocean temperatures, it actually hurts the kind of the heart health of the ocean. And so if it affects its ability to pump hot and cold air and hot and cold water the way that it is supposed to do. And so just like we have to keep our hearts healthy, we have to keep our oceans healthy so that the circulatory system of hot and cold air and water can move. And so that's how this is like disrupting global climate systems in this intense way.
And it is global. And this is why all of the discussion about making changes to the way that we use materials, the way that we create energy, the way that we use energy, like all the things, why they can't just be local discussions. They can be local, but there needs to be global collaboration because this is a global issue. This is not just, oh, hey, it's just going to be a problem, for people in Bangladesh, like whatevs, yeah. And it's interesting, the ocean heating rate from this paper is lower than it was in 1960 to 1974 and 1980 to 1994, but it is still heating and it's increasing. So the 15-year heating rates and the slope of the line is not as steep, but between 2014, 2011 to 2025, we've got numbers on this heating rate, watts per meter squared, of over a half a degree of 0.5 to 1, and it's higher than it. That is higher than it has been. So what we're seeing is an increase. And if every year gets hotter, the ocean has to absorb more heat energy. And if it's absorbing more heat energy, eventually it'll get to a point where it cannot do that anymore, and it will start really putting heat out. And we're already starting to see changes in atmospheric rivers, hurricanes, typhoons, all sorts of things around the globe. But it's someone else's problem.
No, really, there are things you can do. Look in your community, find community organizations that can work together to, try to push changes forward at the city or state or larger level. We want to impact our fossil fuel consumption, like coal, oil, and natural gas. We want to reduce our carbon emissions. But, really, if you want to move the needle, you have to make these large infrastructure level changes. But the only way to do that is to put pressure. And I know it's like really, really hard to feel like you can do anything right now.
So hard,
but that is why it's important to look a little bit more local, because it might feel like nothing can happen at the federal level right now. And that's probably true. We're probably actually moving backwards a little bit at the federal level, but
locally,
you can make big changes. And so, even up to the governor level, there are governors making decisions that will positively impact climate in the 5, 10, 15-year range down the line, because that's the other thing that's really hard to measure about climate change. And it's hard to feel like you're doing anything because you don't get instant gratification. We're not going to see the benefit of what we do today for a while in these graphs and these studies and these, actual real world applications. Also, it's really hard to measure. This is like part of the reason it's so hard to talk about climate change. It's really hard to measure when you've lessened badness, right?
No, but this is everything, right? So it is the problem of vaccination. It is the problem of
I'm still getting sick though. Yeah, but you didn't die.
Right. But or not as many people died, or we improved the outcomes, but it would have been worse. But it's what, and then there's also a conversation about this, like when communication is done right and done well, you never see how much work goes into making it good, effective communication. So there is a schism, and there has been forever, between the sciences and the communications or social sciences, where they're othered, and because it's not looked at as something that everyone communicates. Whatever, I can do it. Yeah, but did you do it without activating a troll army. Like,
Yeah.
but it's the same thing. If we did all the things and climate change, as predicted, never happened,
then they tell us it's full of it. Yeah.
Yeah. People could say, oh, but they were wrong. They were wrong.
Yeah. Really tough.
It is. It's one of the it is one of the challenges for so many fields where a null outcome or a reduced outcome is success, but it cannot be it can be fought through propaganda and biased measures. So this is the place where I feel like we all need to be understanding things so that we can go into changing our behaviors as a choice, and that we choose to do different things. We choose different corporations. We choose different politicians. We choose a different future because we understand the risks and we're ready to fight for that no matter what.
Yeah. Well, and I think the other piece is that, like, the way to actually, this is why systems level thinking is so important, is that the way to actually make change and keep change that is positive and not have everybody go, you are full of it if things work out, is to make the correct choice for the climate and for the planet be easier, be cheaper, be more convenient. And so the only way to do that is to have people be early adopters to new technology or new processes, work out the kinks. So thank you, those people that bought Priuses in 2002 or whatever.
Thank you,
right?
alpha beta testers. Yeah.
Right.
What?
And so that has paved the way to now people want to buy hybrids so they save money on gas, right? So like that is, and people have had them long enough, they know they're not going to break down on the side of the road just because they're hybrids. Like, so you have to have those early adopters who are willing to go the extra mile for the environment in order for it to become a systems level choice. But you also then have to put pressure on civic leaders and, and legislatures and all those sorts of things to make it the easier decision to do the right thing.
Yeah. Unfortunately, there are not as many systems thinkers as other thinkers. But I agree with you. Absolutely. And I think that's, if you make it a no-brainer where it's cheaper, it's better, like, because so often with so much related to politics or whatever, the economics come down to what's in people's wallets.
Right.
And if you make it easy for people and it's cheaper, then people will make that choice more often. Yeah. But anyway, moving on, we've talked about microplastics so much on this show. Microplastics, they're in the ocean, they're in your testicles, they're in my brain. They're everywhere. Microplastics, they're everywhere. What? But there was a wonderful report through The Guardian this last week that is really interesting, because what it does is it pulls together a whole number of comments and scientific discussions around the studies that we have reported on that say, hey, there's, microplastics in your testes, in your brain, in your bloodstream, all over, so many, where we're like, everybody's panicked and everything. Turns out there are, and we know how, okay, on this show, we like the scientific method, right? Which is someone does a study, you publish it, and then there's the comment period where other researchers respond to the paper and make it a public scientific conversation as to the validity and accuracy of results that were published. We have seen results dashed. Remember once upon a time when NASA said that they found, phosphorus light? Was it phosphorus? But like a different life based on a different basic molecule than carbon. And or it's arsenic. That's what it was. Arsenic life in what's that lake in California, Nevada that's really, really terrible. But then it's TWIS and seagulls. Anyway, extreme environment. They sampled stuff. They thought they found bacterial life with the basis being arsenic. A bunch of researchers came back, and the scientific process was they made public comments about what they thought was wrong with the methodology, what they thought was wrong with the analysis. And
Mono
they
Lake.
did. Thank
Mono
you,
Lake.
Mono
Looked it up.
Lake.
Yeah.
Yes, thank you very much.
Yeah.
And so it became a real conversation, but eventually the paper was retracted because enough researchers came out saying, we actually know the chemical assays that need to be done and how these lab experiments should have been done to get rid of bias and get rid of like any potential of contamination. And you didn't do that. And so a bunch of experts said, we don't think so. We've done our own studies based on your methods, and it was not the same. And then the researchers for the NASA paper, they came back and they said, well, we'll try this other thing and blah, blah, blah. But eventually they had to acknowledge that their publication was wrong. They had pushed things forward. They did find some interesting stuff, but it wasn't what they thought. But it was a scientific community that held them to standards. And that's what's happening right now, I hope. And so The Guardian pointed out that in a number of these publications that have come out over the last several years, that there have been commentaries from other researchers who have said that the methodologies being used in these microplastic assays are not controlled properly, that they are not using proper measurement and tactics, that there is probably more uncertainty, that there's more variability in the results than the way that the papers were sold to everyone, right? Mm-hmm. And so you have every paper, because everybody's worried and upset about plastics. Mm-hmm. But what is most likely, and one of the researchers said, honestly, we shouldn't be worried about the microplastics. It's the nanoplastics. But the amounts of microplastics that a lot of these papers are reporting are actually, they would swamp the body's physiological systems.
Right.
And they would very likely not actually make it into the places where they're finding them. And so, and the technique that they use, this vaporization method, that their human fat can often show the same chromatograph mass spectrometry signals as plastics when you vaporize everything, that there are certain aspects of human fat that can actually, not being plastic, just being human fat.
So, this seems like a huge mistake, that you wouldn't put known tissue through the mass spectrometry first.
Yeah. And so some of these studies, they did not do like a human tissues or a cell culture human tissue sample on its own. They did not do a blank. They didn't
That seems so obvious.
Yeah, but there's and that is what is really interesting about what has come forward, is that, so number one, so many, there can be a lot of these commentary papers that are coming from labs that are like corporate plastic company funded, efforts. Like, so there can be that, and we need to be aware that that could be part of this whole thing. But
so the pressure to retract could be coming from plastic companies.
Yeah, right? Exactly. But on the other side of it, if enough people within the that scientific discipline are coming out and saying, you're doing it wrong, you didn't actually take the time to really do as robust a method as you could have. And they are also acknowledging that there is a real problem with, their methods are insufficient to actually be able to get really robust responses because of the way that it's done. So
if I remember correctly, probably 10
Mhm.
years ago now.
Mhm.
The Koch brothers hired some scientists to
Mhm.
debunk a bunch of climate change studies, right?
Yeah, and so this
And
could
what
be happening,
happened
right?
no, but
Yeah.
what happened in the end? Those scientists they hired to debunk the studies went,
They found
they're
it's
real.
it's working.
Right? So if that works, then that would be my hope here is that even if
Mhm.
the motivation behind this is bad,
Yeah.
corporate greed, etc., right? That it if the studies were real, they would still pass scientific muster, right?
Exactly. And so what people are trying to do is replicate the studies. They
Mhm.
are working on trying to get the studies repeated with more stringent controls. So there is work happening within the community, but this it's really interesting because the headline of the Guardian paper was a bombshell, quote, doubt cast on, human mice, whatever. But that bombshell quote came from an ex Dow Chemical Company chemist. So the bombshell, is it really a bombshell? Or is it
Hmm.
just like, is the scientific method and community calibrating? Is it
Mhm.
basically like we've got to, and everybody wants to jump on the hype train with media and sensational. And so the PR stuff goes and goes and goes. I'm just really hoping that we'll see in the next few years a number of studies replicating and repeating with better methods these studies that have suggested that all your testes are full of microplastics. Your babies are full of everything's full.
Should we have
Maybe.
less plastic? Yes,
Yes,
for sure.
uncontested.
Yeah, absolutely. Do we want microplastics in the water? We don't, for
No.
sure. Is some of it in our bodies? Yes,
Yes,
definitely.
absolutely. So that's what I'm saying is these papers and everything, it's not, I don't think it's a bombshell in that it's invalidating everything, but it is what I don't think it's a bombshell at all, but I think it is a scientific field finding itself and
Mhm,
like using the boop 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 boop
mhm.
calibration. Far to the extreme, oh, the other extreme. Let's go, boop, 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 boop. And eventually it'll come to the mean. It'll be fine.
Yeah,
But we have to wait. And that's just the way it works. But
yeah. It's, as often is the
yeah,
way in science, it's not about is it or isn't it? It's how much is it?
yeah. How much is it, right? Some researchers are saying that, false positives are an issue. One researcher uh, said, I have not seen evidence that particles between 3 and 30 micrometers can cross into the bloodstream. From what we
Mhm,
know about actual exposure in our everyday lives, it is not biologically plausible that the mass of plastic would actually end up in these organs. It's really the nano-sized particles that can cross biological barriers and that we're expecting inside humans. But the current instruments we have cannot detect nano-sized particles.
So that's an interesting point, actually. If it's in the
Mhm.
bloodstream, wouldn't every time you got your blood taken for tests and things like that,
They're not testing
in
for plastics.
no, but like in this, I'm just thinking about they always centrifuge the blood, right? So like in
The
the
plastic
centrifuge,
layer.
right? No, I'm
Oh, white
serious. Like
cells.
if there's enough of it, then you would end up with a plastic layer in
Yeah.
blood,
Oh my gosh.
depending how much it is. Again, it's a question of how much, right?
How much?
So I don't know.
It's a
Anyway.
spin test. We'll figure it out. Blair, tell me something amazing.
Oh yeah, hey, there's life in the desert.
Yeah. What do
That's
you
the
mean?
story.
But we know there's life in the
No, I know.
desert. What do you
So
mean?
the Atacama Desert. I didn't know a lot about it.
Mhm.
I had to Wikipedia this because I didn't know. The
Extreme
Atacama,
environment,
it
high
is an
or
extreme environment. as is often the case
pH?
with the desert. It's in South America.
Yeah.
It is the driest non-polar desert in the world. So what I led to believe from that and then found was the case. The driest desert in the world is in Antarctica, which I love. That's so
Yes.
cool. So Atacama is the second driest. It is the driest non-polar desert in the world. It is the only true desert that has less precipitation than a polar desert.
Hmm.
Just a bunch of different. It's also the largest fog desert in the world, whatever that means. This area has often been used as an experimentation site for Mars expeditions, with the expectation that it is this extreme environment. It's most similar to a barren wasteland that you would find on Mars.
Yes.
The expectation is that it's fairly dead. And shock of shocks, hey, they got nematodes in there, turns out. This is a study from University of Cologne.
Nematodes. Wait. Nematodes. They're little flatworms.
Little wormy guys.
Little
yeah.
worms. So this is not brine shrimp.
No.
I
and
just
it's not-
expected brine shrimp.
And it's not just bacteria. They are larger multicellular organisms, these nematodes. They're still small. They're still like microscopic, but they're quite a bit bigger than a bacteria. So they are also just generally one of the most common soil organisms on the planet. They have a lot of different species across the globe, and they have a central role in bacterial populations because they contribute to the nutrient cycle. They poop. And they're also good indicators of healthy soil. So all that to say, like, nematodes in the desert is kind of a big deal. It indicates a much more complicated ecosystem in the desert than many people assumed. I will say I wasn't shocked to read this, also because pretty recently we've had several studies about life in Antarctica. And so I think it's very funny that we have this idea of like, this environment's so extreme, nothing lives there. Things live everywhere on our planet. Things live in deep sea thermal vents that are hundreds of degrees. Like this, just if there is a way to live over the last billions of years, they figured it out. So like, I think, it's more like, oh, this area is barren. We haven't figured out what lives here yet. That's really what they should be saying instead of nothing lives here. Right. Of course, this has a lot of larger implications on what it means to live in an extreme environment, what adaptations are possible for extremophiles. It also, very interestingly, is a type of nematode that reproduces via parthenogenesis, which confirms a whole nother theory that asexuality is an advantageous structure under extreme conditions. So, it's just like, hey, it's really hard to live out here. Sex and sexual selection is really energetically expensive. Also, if there's low population numbers because of the extremes, then, it might just be easier to just clone yourself. And so this just shows a resilient soil ecosystem with nematodes. There's life in the desert. There you go.
But it's not just that it's life. It is that it is life that you normally expect in your vegetable garden soil.
Right.
It is life that you expect places where there is vegetation, where you have richer soil, where you have like what we normally would look at as a more complex environment.
Mm-hmm.
Because the nematodes are part of the nematodes are part of the ecosystem of the soil that add the nutrients to the soil, that make the soil what it is to support life. And so the fact that they're there means that there's the stuff to support them. But was the abundance of the nematodes versus different ecosystems? Was there a difference there?
Yeah, good question. I don't know. I did not see that in this. But I think the thing that if I were an ecologist or a geneticist, the thing that I would be super excited about from this discovery is that because nematodes live in a bunch of different types of environments, you have your garden nematodes, you have your rainforest nematodes, you have your like Antarctic nematodes, and you have your desert nematodes. That means that they are all fairly closely related and adapted to vastly different biomes. So,
Right. So
as
nematodes are a diverse
ecologist
Yeah,
or a
all right.
geneticist, this is an excellent opportunity to
Yeah.
compare different types of nematodes that live in different environments, because you can look at what genetically is different about them. You can look at what ecologically is different about them. What are they eating? How are they reproducing, as we talked about, right? What do they provide to the ecosystem? Is it the same in both cases? What makes them thrive or not in those unique ecosystems? There is a really rich opportunity. Like whenever you discover new extremophiles, there's a really good opportunity. There's like a really rich vein of research that can come out of that, because there is so much to explore. Because we've studied, I'm not going to say like very thoroughly, there's so much still to learn, but we've studied a lot about rich ecosystems, about rainforests and, temperate forests and coastlines and these places where people live, or where it's beautiful, or where it's teeming with this like macrofauna wildlife. It's very easy for researchers to go and say, what the sloth that poops seeds, and it's the gardener of the rainforest, and it has algae living on it. It's like all this very big, larger than life interactions that are happening, but
And
in
it's
the
so visible
sands,
and so exciting.
yeah,
But yeah, what else is going on?
in the sands of the desert, you have bacteria and nematodes working together to enrich the soil. So like there's a vast world that can be explored when you discover an extremophile like this, by compare and contrast and by further studies. So it's pretty cool.
One of the things they say at the end of their abstract is that the findings can provide new insights into the mechanisms shaping biodiversity in arid ecosystems. Those are growing around the world, and can inform predictions about soil resilience under global climate-driven aridification. And I think this is one of the big points, the climate-driven aridification, where we have water moving from one area of the world to another. And so we have the expansion of deserts, the growth of new deserts, and soil for humans is something that's absolutely essential, because we use it for agriculture, right?
Kind of important to eat. Yeah.
And we look at it as the importance of agricultural soil. And we know that there is a problem with topsoil around the globe because of agricultural practices. But the question is, other places in the world, how will the soil act? How will it grow? And also, how can we get desert nematodes and stick them in your garden and make things better? Like, would it work?
Or would they all die because it's too wet?
Right. So there's some, I don't know, I feel like there's some very interesting questions there as we move into the future, because not only are the animals moving, but and the plants and the insects, but people are moving too. So we have to know where we're going to make the next.
I think I'm gonna pass on the Atacama Desert. I'm okay.
No, we don't need to go to the Atacama Desert unless it is just for a short trip to experience the extreme aspect of that environment. But it is a delicate, beautiful environment, and if you do get a chance to go, be careful there. Not for yourself, but for the environment. I mean, I think you got to take care of this stuff. Last couple of stories for this first part of the show. A story out of ETH Zurich, the Energy and Technology Policy Group. They have published a study looking at the feasibility of electric vehicles in Africa. And previous predictions had put the growth of electric vehicles and the feasibility of electric vehicles like farther off, 2050, much later, even though here in the US, other places, the EU, like China, various places, we've got electric vehicles and infrastructure growing at a rapid pace. So what they looked at is whether or not the 2050 number was correct or whether whether it's going to shift. And what they found is that electric vehicles could actually catch on in Africa much earlier than expected, thanks to things like off-grid charging systems that are solar powered, economically competitive vehicles from countries like China, that because of the way that Africa is a large continent with many countries, and so it has a very diverse political and energy infrastructure ecosystem. But the main point is that overall, that much of the energy in Africa is off grid. That there are a lot of people using solar, using wind, using various methods to charge batteries for their villages, for multiple purposes. And so as a result of the fact that independent of the grid, energy production is growing at a very rapid rate in Africa, at the same time that we have vehicles being created, not just the cars from China, but also e-scooters, like e-bikes, scooters, small motorcycles, vehicles that would not need as much of a charge. But basically, all of the parameters come together to suggest, based on their calculations, that a compact solar system is enough for a small car that travels about 30 miles a day, 50 kilometers. The cost of charging accounts for only a small portion of the vehicle's cost. And so really, some of the biggest challenges to the adoption of electric vehicles across not just Africa, but the globe, is that as you move away from internal combustion engines and a distributed network of gas stations where consumers can be taxed for their vehicles, for their road use, for all that stuff, because they need to come in and get gas. As you move to electric vehicles, especially those that are off grid, you no longer have a mechanism to pay for infrastructure like roads. And so there is it's chicken egg, right? But it is basic. If we want to fund infrastructure like roads communally, then how do we make sure that the electric vehicles somehow, because as we move, they are included in the paying for the use of that stuff without just having road fees, right? Where you have to come to a gate pay.
I would pay a toll for a road if it wirelessly charged my car. Yes,
like if you come in, it goes beep beep. You're wirelessly charged.
It's like a fast track or whatever else. Like you'd get scanned just like you do for the express lane or for a bridge toll, but it's for a charge road.
Yeah. Yeah. Well, anyway, it is estimated based on this study that battery electric passenger vehicles will be cost effective across Africa well before 2040 and possibly as soon as 2030. Which is just 4 years away. So because of the fact it's the energy independence is depending on the country, depending on the state, depending on so many factors, but it's so interesting to see a different continent, a different system, and one that has been subjugated and colonized for basically as long as like Western culture could come back and colonize it. I don't know. I'm hopeful. It gives me a little optimism.
Well, I also start to think about like all the ecotourism that happens in Africa. And it would be great if all of those vehicles could be solarly charged and be electric.
Right. Like, what if your safari Jeep were electric? What if, like, and you have extra batteries in the Jeeps that power the camp. So you drive out and you have a generator also, but there's like and solar so that maybe you can, while you're out safaring, also top off the batteries at camp. Like there's so many ways that that kind of ecotourism could not leave as much of a dent.
Well, also there should just be solar panels on every car roof. Period. Like the roofs are right there. Just get it done. Anyway. Well, that's great. I'm pretty excited. I love stories like that also because, like, to loop it back around to the whole climate change conversation we were having earlier, it's really nice to hear about potential advances in environmentally friendly policy or, systemic changes or structural changes in like the infrastructure in places outside of the United States. Because
exactly.
it can feel really heavy if it feels like
it's just us.
It's up to us.
No,
Because,
there is a whole world out there. And the reality is that India has almost 2 billion people. Africa is one of the most rapidly growing populations on the planet. African countries are set to reach billions and grow from there. Asian countries, billions of people. There are 313, somewhere around there, million people in the United States. We are big spenders, which is why we put this pressure on us, and we've told a narrative to ourselves that we're awesome and that we lead the world. But the reality is we are smaller than so many other nations, so many other continents, and we don't need to be, nor are we necessarily the leaders in stuff that's going to make the world better.
Yeah. We're up there and we have to kind of keep our head on a swivel and do what we can, but it is really nice to know that we're not in it alone.
We're not.
And also other places are working on this. Other continents, other countries.
And it's like what I think is so exciting is that the countries of Africa, many of them are coming into their own strength and no longer accepting the colonial dictates of many corporations and countries. I mean, a lot of them still are, so I'm not just saying like, well, whatever. But there is a movement happening now for these countries that historically have been kind of kept at a third world level because it was convenient for our resource extraction. And they're going to help themselves. Like, if we don't help them, they will help themselves. They will help each other, and they're gonna do big things. And they're bigger than us. So anyway.
Yeah.
Anyway, so that was another one. But moving on to red hair, because I got some red hair in me. Apparently red hair can be a positive thing, not just something that leads you to having cancer. So everyone out there who's a ginger, pay note. A study came out January 6th in PNAS Nexus looking at a molecule called pheomelanin. It is a sulfur-containing pigment produced by melanocytes, which are the darkening color cells in our skin, and notably in people with red hair and fair skin, animals like orangutans with orange hair, light skin. It's not photoprotective. Usually it doesn't do anything. It doesn't it's there and it gives you the red hair. And everybody's like, what good does it do? It just says that you have a higher risk of skin cancer. But apparently, this study looked at the mechanisms related to the production of the pigment and found that they are necessary for the reduction in the quantity of the amino acid cysteine in your body. When cysteine builds up in the body, it can cause, it can be toxic. It can cause issues related to cancer. It can cause other issues related to oxidative problems, aging. Like there's a lot of stuff. Cysteine levels go up, your skin health goes down, your body health goes down. It's not great. And this is great because they used zebra finches, birds, because zebra finch males have like really pretty orange feathers. And so they looked at the males with like really bright feathers versus the males with not so bright feathers. And they were like, oh, look, they manage their cysteine levels better. The brighter orange males are healthier and stronger and aging more slowly than the low orange males. And then they found a molecule that was like, we can block the production of the pigment. And they messed everybody up. And they showed that the increase in cysteine levels it was messed up. And so in the birds that normally turn cysteine into this melanin, this type of melanin, pheomelanin, a pigment, those males that were healthy became less healthy. And moving on from this, what they suggest is that redheaded people, because
this is a jump.
Well, it's the same process. It's the same mechanism where it is a physiological process for dealing with too much cysteine. Anyway, and it's a cost benefit thing. So the redheads, they might get cancer, but they're also going to be healthier in other ways. Oh, but they're also all related to Neanderthals. So never mind.
How are we? Okay, I take your word for it. But I still think, okay, at least do some mice. Mice come in pretty colors. Pick some red mice.
They don't.
Yes, they do. They absolutely do.
I mean, not red-headed mice.
Yeah. Yeah, they're like orange.
Well, anyway,
red, like the finches are red, I would say. I'd say it's pretty similar.
It's a bright orangey red. It's a ginger color.
Yes. Yes. So you could take some redheaded mice and you could see how they handle cysteine. Like I really feel like I'd want to see this in a mammal because it feels too different. But
we have talked for a long time about how animals have mechanisms to display their health. And an animal and these orange patches are signaling to other mates, prospective mates, that they are super healthy, right? So these males who are able to deal with their cysteine by turning it into bright orange feather patches are able to signal to potential mates that they are healthier and they'll live longer than another less brightly colored individual. So it gets back to, and yes, I agree, the jump to red hair is like, it's a jump because they did not do that. They studied zebra finches. But if cysteine is toxic, and if cysteine needs to be dealt with and there needs to be a mechanism to deal with it, how interesting that some individuals came up with a way of dealing with it by turning it into a red colored pigment that could be expressed in the exterior tissues as a signal of health and how well
Mm-hmm.
they're able to deal with toxins. So I don't know. I feel like this is one of those mechanisms. This is, where you have like the 4 questions of evolution. This is getting at some of the more intrinsic mechanisms and the more, I guess, not explicit, but like the external behavioral result as well.
Mm.
I mean, it didn't have to be turned into red.
Yeah.
But it got turned into red. And if it's with birds, zebra finches, who like mammals came, so there's reptiles and birds split off of, like, there's the dinosaurs, reptiles, birds split out in there, and humans came off at a weird point as well. Like, how far back does that go? And is this something that is conserved?
Mm-hmm. Interesting. Well, because if it's a signal, why would mammals keep the same signal?
Do they?
Well,
Like,
that's what I'm
this is-
saying. Like,
So this is the
if the
question.
signal is that I have red hair and therefore I'm more tolerant to cysteine, I'm healthier,
I'm
whatever.
healthy, I'm bright and fantastic. Yes.
I think that's the question, because also, like, colors mean different things to different species. Like, sometimes a bright color actually means I'm poisonous.
Which is
sometimes
weird-
it means I'm
Yeah.
ready to mate.
Mhm.
It can mean any number of things. So I think that that's the part where you kind of lose me, is like it.
I'm gonna just like add this
Yeah.
little tidbit. Pheomelanin, this red tinted melanin. Pheomelanin production is concentrated in the lips, nipples, and genitals in humans, but redheads also have it in their hair and their skin. So it is a sexual signal in humans as well.
You got
This is why this is so fascinating.
Weird. Okay. Interesting.
Like, for all the things about red lipstick and whatever and blah blah blah, but like,
it's a sexual
why
signal.
did red become a signal for mating in humans even, right?
Yeah. Huh.
And then redheads have it in their hair and their skin. And then everybody goes, "Oh, ginger, witch, what?" Anyway.
Oh my goodness.
Yes, we're going to keep going here. This is This Week in Science. Thank you, everyone, for joining us for another episode of your favorite science discussion program. So many good things here. If you want more good things, we'll be back again next week. But we really rely on your support. So if you are able, head over to TWIS.org and click on the Patreon link. Become an ongoing supporter of the show. The Zazzle link will enable you to go to our store and find goodies. A lot of them art created by Blair. Some great stuff in there, great products. And it comes back to support the show and make sure that we can keep coming to you week after week. And as we do this, I just want you to know we know the world is full of all sorts of requests. But if you spend time with us and you appreciate this time, please help invest in the time that you spend here. It will help out a lot. I don't have any more to say. I'm not going to say anymore. I have so many things to say, but I'm not going to do it. Thank you for your support. We really can't do it without you. Oh, I was going to say thank you to everyone who donated extra amounts, not through Patreon, but through the PayPal interface on our website over the holidays. It gave us a little buffer at the beginning of the year this year that it was really, really appreciated. Thank you very much. I see you. Now it's time to come back for this part of the show that we love to call Blair's Animal Corner with Blair.
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your
jargon, except for giant pandas and squirrels animal corner.
What you got, Blair?
I have bee tongues.
How many?
At least half a dozen. Anyway, bees, they forage for nectar. The way they do it is pretty cool, actually. They have this like long proboscis. They have this tongue covered in little hair. And so they kind of work through capillary action. It's very cool. And so these little hairs that are together, that are very close together on their tongue, allow through capillary action, the nectar to just kind of suck up across their tongue and into their mouths. And so researchers wanted to look at how this tongue works, and specifically why queen bees don't harvest nectar. Like, obviously, they're very busy. But where did this caste system work? Like, why do they actually will harvest a little bit of nectar, but once the workers start emerging and being born and are old enough to actually start working, they kind of take a step back and they stop harvesting nectar pretty much completely. So first, researchers did a postmortem scanning electron microscopy, and they looked at also in live bees high-speed filming so that they could see the bee tongue of worker bees and queens and provide the morphological and physical evidence for the difference in specifically the tongues of these two different bees within the same colonies. And so while hair spacing starts out very dense, it increases more slowly than tongue length when they grow. And so as the queens get larger and larger, the hairs actually are farther and farther apart. And so by the time the queens are nice and big, it essentially creates porousness where the capillary action no longer works. And so the nectar retention on the queen's tongue is way less effective. And so they basically just give up drinking nectar and harvesting nectar because they can't. They're just bad at it. It feels like the weaponized incompetence of like, you're so much better at it than me.
I know. So feed me. You're better at it. So I'll eat what you bring me. That's great.
So the reason I found this so interesting is that they're kind of a victim of their own success. The queen bees have to get nice and big and fat so they can create lots and lots of eggs. And so because they're getting big, their tongues are becoming less and less useful as they grow large. So what I am so curious about is how did this happen? What is the chicken and the egg of this whole situation? So is it really just a result of the queen bee grew bigger, the hairs couldn't keep up with the size, and it just worked out because they were worker bees? Or was it, I'm not going to put energy into something I don't need, so it was evolutionarily advantageous to not get a furrier tongue as you grew larger? Or is it a trade-off? In order to get large, you get worse at harvesting nectar, and therefore a successful colony, because that's the other thing. You think about bees less as individual organisms and more as the colony as an organism. So if you think about it that way, it's almost as if it's like an organ that lost certain things that other organs do because it doesn't need it anymore. So the queen bee is more successful when larger, and therefore the worker bees will harvest the nectar so the queen can get large. And if the worker bees weren't as around or as successful, then the queen would not grow as large, right? Or so I think that's the part that, my brain just starts going in circles, and it's hard to know the evolutionary origin of this. Why did it happen this way? Was it a happy accident? Was it an actual evolutionary trade-off? Really, really hard to identify.
But we have to go back to like the origin of the queens, which is that before they become a queen, they are fed royal jelly. There is like a whole nutrient cycle that is different with potential queens from any other quote unquote individual in the hive, right? So does that start the process? Does it create feedback loop where the metabolism of the queen bee is predisposed to growth and reproduction at the like cost of foraging? Grow faster, the tongue hairs can't keep up,
right?
Like, I don't know, that's what I'm wondering is, you can't just say it's the queen, and they do keep feeding her, and she grows bigger and she makes the babies and all the things, but
right,
yeah,
or is it
before then.
Right. So is it really just social dominance where she stops harvesting nectar because she's the queen and she's laying eggs and she's busy doing other things? And so evolutionarily, it makes sense not to push energy into keeping the tongue going because she's not doing it anyway. Or did she stop harvesting nectar because her tongue sucks? Right. So like that's the part where I just kind of over and over, look at the little tongue. Tongue. Yeah, so I think I'm getting so distracted by this adorable little tongue. I actually, a couple times, when I still worked at the zoo, we would get these huge bumblebees. And it was specifically out the back end of the education building where I worked. I would see these bumblebees all the time. And every once in a while, one would land on like a fence post or a flower, and you could get up real close to them and you could see their little tongues sticking out just without any magnification or anything. And it was the most glorious thing to watch. This little bee lapping up nectar. Just so cute. Yeah.
Cute. They get a bad rap by people who are afraid of the toxin, right? The it's not a venom, it's a poison, but like they're, but bumblebees are different. Bumblebees also have it, but there's so many amazing bumblebees out there. It's not the same as the honeybees. Bumblebees are awkward.
They're so cute. They run into everything. Oh my gosh, I love them. Yes.
And the ones that, like, there are so many also that are the cavity nesting solitary bees. And they are cute and amazing, and they're not violent, and they just want to make sure their babies are okay. But they're so good. They're amazing.
Yeah,
I love mason bees. They're so great.
If you want to help bees in your area, now's not a great time because it's winter, but in the spring, or even in the winter, actually, you can, especially like late fall, early winter, if you're interested, you can make bee hotels in your backyard. And so solitary bees can actually use your bee hotel to spend the winter if it's going to be safe. But then in the spring and summer, you can also make bee baths. We used to do this at the zoo all the time with campers, because, a bird bath is for birds. A bee bath is usually like a plate with a bunch of rocks in it and a little bit of water. So it's a lot of little opportunities for shallow water with little shallow pools where bees can land on the rock and lap a little bit of water or bathe in very shallow water and then take off. So you can make little bee baths. Clean them out at the end of the day. Don't leave them there all the time. We don't want to harbor bacteria or disease, especially for birds and things. But you could totally make a little bee bath for your neighborhood bees in the spring or summer.
Oh, I love that.
Yeah.
Little bee bath.
And you can make a bee hotel too, which I love.
Oh my gosh. And
Anyway,
it's not that hard. It's like a bunch of holes drilled in a piece of wood.
yeah. Or
Very easy.
you can
Yeah,
some
awesome.
people make it with like toilet paper tubes, and then you can kind of put stuff in them to make them a little more tight, like ball up pieces of paper, or sometimes people will use like tree cookies and just kind of build them kind of sparsely so there's cavities in between them. There's lots of different ways to make bee hotels. They're really cool.
I'm the worst landscaper because I like as soon as I find an insect or like anything interesting in the ground, I'm like, I can't rip out this ecosystem. And so then I leave things in the ground and try to always rip out the ivy. But like as I'm doing it, finding these little solitary bees doing the thing. And I'm like, oh, I destroyed your home. I'm so sorry. I'm the worst.
Oh my goodness. It makes sense, but also by removing an invasive species, you might let a flower with delicious nectar.
It might get better.
Instead.
Yes.
Yeah.
That's the goal.
Tough.
That is the goal. Yeah.
Hey, AI, do we like it?
What?
AI.
It's fraught.
It's fraught. So the big problem with what everybody's calling AI, and as many of our listeners will say, it's not really AI, it's like machine learning or algorithms or whatever. The issue that we have in conservation with AI can be the same thing as what we're having in like social circumstances, which is it's getting harder and harder to tell AI from reality. And so in one such example, in St. Louis right now, there are some monkeys on the loose. That is real. There are some vervet monkeys. The problem is unclear how many, unclear where they came from, unclear where they currently are, because people are finding it very funny to make AI videos about the monkeys. They are making AI videos that they caught the monkeys. They're making AI videos that they're places that they aren't. And so the Department of Health and Animal Services in the area also are really having trouble sorting through the AI content and the real content. Also, just general humans will go chasing, looking for the vervet monkeys, or they'll be scared to go places because they think that they are on the loose still. And so as of Monday, I haven't heard an update since then. The monkeys were still at large there, but it's causing a lot of kind of uproar. And primates are not
nice
pets. Yeah. They
they're not.
They're not pets.
Zoo monkeys also have not been trained by like the capuchins that you think of as organ grinder monkeys, or the ones like
Marcel from Friends, right? Yeah. Like
if there's monkeys escaped from a zoo or a sanctuary or whatever, they're not going to be friendly, nice monkeys.
Right. And the problem is they're not from the zoo. Okay. Nobody has claimed them who has permits to own monkeys. So
where'd they come from?
Very unclear where they came from. And if they're caught, they're not going to go back to the people that if somebody had them as an illegal pet. So that adds to all of this. Not to mention that when you add AI videos in the mix, you can often show, like, people show that they caught them and they're in their house and they're being friendly and they're doing cute things. So then it also kind of removes some of the healthy concern or like cautiousness that we would have around these animals. So this is kind of the secondary piece, is that I am starting to see more and more videos when I go on social media of animals doing things, and about halfway through I'll go like, oh, that's fake. And it's because I'm not good enough to recognize AI and not AI at this time. Like, I don't spend enough time on the internet. I am not a developer. I don't know anything about AI algorithms. Like, I am not good at recognizing the artifacts that tell me it's AI. The only thing that I can currently do is use the context that I have, which is, oh, a bear would never do that.
Oh my gosh.
Yeah, so it's
That's not normal.
Yes. So I just saw some raccoon videos the other day that somebody sent me and they thought it was so cute. And I'm like looking and I'm like, well, that's not okay, but maybe. And then I
They
see
wouldn't.
more and then I'm like,
You go,
I
no,
don't know if,
nope.
and then they did something else where they were kind of standing in a way that raccoons can't even stand. And I was like, and there it is. And so it's, if you're just a person on the internet who doesn't know about monkeys, you'd think this is real. You might see then these escaped vervet monkeys out in the world and think that you could approach them. So that's where this gets really complicated and scary, because you're removing the natural safeguards that we have in our body and our brains, telling us, like, the animalistic instinct to leave wild animals alone. We're now training that out, not just out of like cute loris videos, which are their own issue from before the AI era, but now we have fake content that is making animals look less dangerous than they are. So, like, it's kind of a mess.
I don't know. We're going to see even more. Oh, I didn't think the leopard would eat my face kind of situations.
Absolutely. And there was a second actually story about AI and animals that I just kind of wanted to tack onto this, that was originally like hey, AI's helping animals. And it's because of facial recognition of bears.
Yeah.
Which is overall good. Because there are things called problem bears. So in bear management, so let me take a step back. Bears, they need a lot of space. They have huge habitats. And so when humans started expanding, specifically across the Americas, they kept fragmenting bear habitats. And so if you put a town in the middle of this huge area that bears used to be, they're going to wander through your town. They need big spaces. So if you think like, oh, but there's a forest right there, doesn't matter. That might not be enough forest, or that might not be where they were before. They might have lived where you are now, right? And so bears have a habit of entering into human spaces, also because most bear species, scavengers, most bear species will eat anything. And so they're going to go for easy food before they hunt. And that usually includes grain silos, garbage dumpsters. So this is where bears go. And so when humans end up in common space with bears, that can cause bear-human altercations, which can be very, very dangerous, because bears, if they say like, oh my gosh, I have found this all-you-can-eat buffet that is this dumpster in this town, and now a human's trying to shoo me away, get out of here. Like, this is my food. And so they're going to protect themselves, right? And bears are big and dangerous and deadly. And so when we have these problem bears who have habitually found that they're going to keep entering human spaces, they have to be relocated or euthanized, because otherwise they are a threat to human safety.
And the thing about this, yes, a threat to human safety, but they are just doing like intelligent animal skills. They are like taking advantage of resources that are nearby.
Yes.
And who cares if the dumb human got in the way? I will, punt them out of the way as I get into their car, or, whatever.
Yeah.
It happens.
Yeah. Well, and so like here in California, we don't have grizzly bears anymore. The grizzly bear is on our state flag. We don't have any. No brown bears, no grizzly bears. We don't have any. We just have black bears now.
Oh, so only black bears?
Yes. Yeah.
They're smaller, right?
Yeah. Yeah. They're smaller. They're derpier. They eat mostly vegetables. If you yelled at them, they'd probably leave.
Is it because we killed all the other ones?
Yes, exactly. So that's what I was getting at. So in California, we're pretty densely populated. And so the decision happened when westward ho, right? We're all expanding. There's gold panning. There's people everywhere. They were basically just eradicated. They were exterminated. They were in the way, right? And so, no matter what you say to that, at the time when that was happening, that was the solution that was deemed appropriate. And so there aren't bears here anymore. And in other places, like in many parts of Canada, in in a lot of our huge national parks in the Midwest or in the central parts of the United States, there's still bears because they didn't end up as densely populated as the coasts. And so they weren't fully eradicated just because logistically it wasn't necessary at the time. That's really the only reason. And so now, as populations grow and people are more mobile and all these sorts of things, there's still bear altercations in these spaces. And so that's
Every
why
national
now,
park, so Yosemite,
Yeah.
Yellowstone, like
Yeah.
you name it, it's always warning about the bears. And
right.
yeah,
Yeah, and so now the issue is you have to kind of because you're not just going to shoot all the bears like you did in the 1800s, now you have to kind of make these informed decisions and say, this is a problem bear. We have to move them or euthanize them. And then this is not a problem bear. We are not going to mess with this bear, right? And this is where AI comes in, because they need to identify the problem bears versus the non-problem bears.
I love this is like a weed versus just a plant, right? It's like
Yes.
they're all the same. It's just some were better at taking advantage of resources and growing places that other plants couldn't, right? And they're usually places that people don't want them to grow. Hence,
Right.
weed.
Yes.
Right? So problem bear, just the
Yes.
wording there to me is problematic, because
Yes.
really it's just like, okay, so you have some bears that are not willing to just listen to the human the human signals of go away, and to learn those and just go away and go somewhere else. These are the smart bears who, these are the anti-authoritarian bears.
Yes. Yes. That's right.
Okay.
Yeah.
So now we're doing facial recognition on anti-authoritarian
Right.
bears. Thanks,
Right.
Blair.
Right.
Okay.
So previously, you had to kind of rely on people whose job it was to identify bears. And you'd have to kind of go, okay, the bear expert over here tells me that's not the bear we're looking for. Or in the case of a bear in Canada, last year, a couple months ago, they actually had to trap several bears. They trapped 4 different bears in 4 different instances. They sedated them, they helicoptered them, they tested their DNA, and they tested their DNA from the attacks on humans of this problem bear, and determined that it was not the problem bear. All 4 bears was not the problem bear. So then they had to re-release the bear. Obviously, that's a huge problem, because you've relocated a bear you didn't have to. Honestly, more likely to turn that bear who's not a problem into a problem, because you relocated them, because now they don't have a place to go. Now they have to learn a new area. They're more likely to stumble into a town. If they're sedated and you plop them into another bear's territory, that could be lights out for that bear, right? So there's also any sort of medical complications in sedating and physically moving a bear, right? Lots of different things can happen. So aside also from that being time-consuming, labor-intensive, and expensive to do DNA tests and sedations on random wild bears, right? So potentially doing an AI image check would be great. And so for identifying bears, there's this new facial recognition tool called Bear ID that is under development. And so hopefully this can be able to be used to identify individual bears. But the one thing to keep in mind here is that focusing on individual animals in wildlife ecology can be a problem. So the biggest problem being that it's kind of what you're talking about, Kiki, that like just because one bear was smart enough to go to the dumpster, if you remove that bear, were they also dominant in that area? And now another bear is going to go to the dumpster?
Right.
Or do you
Because
need to figure out ways?
That was the
to, like-
territory, and then you removed it. So now there's a hole, and another bear will come into that territory. So you
Right.
have another quote unquote problem bear.
Right. So, or is it that your dumpster is flawed, or you need some sort of bear hazing at the outside of your town near the forest? Or is there something that you can do to exclude bears from that space beyond removing an individual bear? There's also, because there's imperfect bear ID, do you think it's one bear and it's actually 3 bears? So it's kind of an imperfect plan overall to identify and target individual bears. This would reduce the ecological impact, financial impact, all these sorts of things of trying to do things the hard way. It can make it much easier for them to identify individual bears and remove problem bears. And specifically, if there is a fatal or near fatal altercation, it is a good idea to remove that bear from that scenario. I understand that. And so being able to do that with facial recognition technology is great. But it's on the whole, the kind of the philosophy of removing individuals instead of adapting to ecological zones that butt up against civilized areas or urban areas or suburban areas, like that really is the thing that needs the focus. The other thing is that also, you always kind of have to be careful with these models. Is like, is the goal bears or is the goal humans? Like, are they training this system to then later be better at human facial recognition?
Yeah, it depends. It depends, but like, I mean, like, I want the app, next time I go to Yosemite, I just want to have the app and be
Who
like,
is this? Yeah.
Oh, hey, Bob.
It's
there.
Charlie. Yeah. Well, so actually the researchers do mention this too, that there is a danger in that. Because if you give people the tools to identify individuals, name them, like give them personalities.
Yes.
Then that also does remove some of the danger, just like we were talking about with the monkeys, where it anthropomorphizes them enough that it could actually make further problems.
Yep.
So that's another thing you have to look for. But.
Oh, this is barely a problem.
Ooh. And then my very last story today, late breaking news, just sent directly from the good doctor today.
I might have.
Yes, is deer scrapings. No, it's not me scraping bits of a deer. It's the deer scraping on trees and rocks and the ground, with their antlers, with their feet, peeing on things, all those things. Turns out they glow in the dark.
You love glow in the dark animals.
I
know. This is the whole thing. Like, you have a list, an ongoing list of like all the glow in the dark animals. And I came across this study and I was like, I can't believe that you missed this one. But I didn't
see it. Yeah, no, I love it.
It just came out. So I just, knowing how we've talked in the past about how we base everything on our human visual system and how we did not prepare for all the other ways that other animals can interpret signals and what that would look like or smell like, or whatever outside the human sensome. But like, I think it's fascinating. Like, I've always wondered. So it's like mice leave their little ultraviolet pee trail or their whatever trail, like their little path. And it's interesting because then we know the birds, owls, like that birds can see in the ultraviolet. So it also makes it easier for birds to be able to see where the mice might be going. You have moths and other nighttime organisms that have this ultraviolet display, right? That might be for each other or to confuse a predator, right? But it's something we never thought of and we never talked about in the last few years. We're like taking a black light to everybody.
Yes. So this is the part where my brain really started to struggle, because I learned now that rats glow in the dark, moles glow in the dark, animals are leaving glow in the dark pee trails. Now we have deer, every tree they scrape their antlers on, every floor they scrape their foot on. So they have glands up in their head, and so that's secreting an oil that is then glowing in the dark. They have glands between their hoofs, between their little toesies. Those are secreting oils that glow in the dark, and then their pee has this glow in the dark stuff. So it's just every place they're marking in one way or the other, they are leaving a trail saying, I am here. Now, I understand, especially male deer need to mark their territory so that other male deer buzz off, and also so, they can tell a female deer they're in the area, and then the female marks and says, I'm in heat, and then the male goes, rah, rah, rah. So I understand the point. And so ultimately, this study is saying that it is olfactory and visual cues now. And so that's the big change, is that there's visual cues in addition to the olfactory cues. Here's where you lose me.
Okay. That's okay. Good.
They're prey. Why are they advertising so heavily where they are? That seems like a mistake. Just like with the mice. Why would you advertise the trail of pee that leads directly to where you're going, to a predator, to an owl? And so this is where I have a new theory.
Awesome.
Is that basically everything's UV. So animals see in the dark. They can just see. They see as well as they do in the day. They just see everything. And so like we keep going like, this is glow in the dark, and this is glow in the dark, and this is glow in the dark. But really, to animals who are awake at night, it looks like a laser tag arena. Like everything is outlined, like you can see everything, and it is a byproduct. It is not intentional. It is not a function. It is a byproduct. Like things that are alive glow. Like this is my new theory.
Okay, so this is where I'm going to come into it, because you know how many like crime shows go in and they put the UV into a room and they're like, oh goodness, it's a crime scene in here. So our bodily fluids glow under UV light.
Yeah.
We can kind of see that during like golden hour. Like there's the certain hour of the day when the wavelengths are shifting.
Okay.
And you can see how the blue flowers glow like a little bit more blue. Like we don't see the invisible blood stains.
Right.
But we don't have the same nocturnal lifestyle or visual system, and yet our fluids do the same thing. So the question is like, everything glows.
Yes.
There are some animals that use it as a map, and others it's just like you said, just a byproduct, and they don't even know they're doing it.
Yeah. So
Or,
deer are crepuscular. They're awake at dawn and dusk. They are not nocturnal. So
but that's low light conditions.
Right.
And their eyes are huge with like
Yeah. So, but that's what I'm saying is like they're not walking around at midnight going, where's the other deer? Right. So it's if I was a predator who was nocturnal, I'd see these deer spots. I know there's a deer in the area. I might not know where the deer is sleeping.
There's a paragraph in this paper I'm just seeing. Deer vision is adapted for heightened sensitivity in low light conditions. So the crepuscular aspect. That's also when the mountain lions, like the cats who are going to come take them down, the predators are going to come get them. The optical lens of the deer lacks substantial pigments capable of filtering UV light, but they've been hypothesized to be visually sensitive to short wavelengths that predominate during crepuscular hours. So the photoluminescence, it's very possible that like there's some aspect of the deer visual system that makes them more sensitive during that low light period.
Yeah, which ultimately is it all just noise? I think that's the part where I kind of,
when is it noise and when is it signal?
Yeah. And if you're a deer in the woods with lots of deer, every single tree has this on it. Guaranteed.
Yeah.
So how much is that actually telling you? Like, you still have to go there to smell it to figure out, is this a female in heat? Is this another male? So you can see there's rubbing there, but I'm going to guess pretty much every tree has rubbing on it from a deer.
And many from many deers.
Yeah, absolutely.
All the deers. But I think it is something that we do not understand well enough. And we don't understand, like, we're not in deer society. We don't understand. We don't know what they're paying attention to. We just make guesses. Yeah. Oh, biologists. And now I have a couple of stories, which is similar, but for humans. We have neurodegenerative diseases that occur as a result of the buildup of toxins and metabolic products that are not, somehow they don't leave the cell. And so researchers have just published in Neuron from Baylor College of Medicine this last week their work looking at neurodegenerative diseases like ALS, amyotrophic lateral sclerosis, dementia, other things. And what is known is that in the neuron, in the cell, the membrane is the place, like everything's held inside of the cell. And then the membrane is where there are pores that are like the little tubes that all the garbage, you can either like take a vacuole and excrete it out into the extracellular space, or you have pores that just, they're matched to the biophysics of various molecules so that they move them out against the chemical gradient. However, what they've discovered is that this doesn't happen all the time, and that in ALS, many times the pore is the problem. And so what will happen is there's a protein called TDP43, and it just doesn't go through the nuclear pore the way that it's supposed to. So it gets lost from the nucleus, but then all of it, it just builds up in the cytoplasm, and nothing breaks it down, and nothing gets rid of it out of the cell. And normally there's quality control in place through the cell that is supposed to go around and make sure all this stuff works right. But sometimes it gets broken. And so they've moved on from this particular TDP43 trafficking problem and been looking at a protein called velocin containing protein, VCP. VCP is in all cells. It is quality control. It recognizes damaged, misfolded proteins, and it is part of making sure they are sent out of the cell, that they're extracted. Usually, it's active and it does great, but when it gets overactive, it removes proteins that it shouldn't remove. And so this is the issue with the mislocation of the TDP43. The pore that deals with TDP43 is impacted by too much VCP protein. The VCP protein basically it turns off the pore, so the pore, or it shifts the pore, so the pore is broken, so that this protein that is normally in the nucleus goes to the cytoplasm and needs to get moved out of the cell, and it normally is moved out in a very regular way. Suddenly, the exit door is closed. And so they're looking at, there are cancer drugs that inhibit this VCP. However, you can't just like block VCP everywhere because it is in every cell. And so you would mess up a lot of tissue and organ function if you did that. And so for the very specific aspect of the neurodegenerative process and ALS and other dementias, what they're trying to do is see how they can, whether they can find VCP protein inhibitors in the cancer drugs that we have currently that are more focused on just neural tissue, or whether or not there's some way we can find a target that just goes after what's happening in the brain as opposed to everywhere. Yeah.
Can you take it a step behind that? Like what? How do you?
So there's also, why is the VCP overexpressed? Right? Why does it build up too much? That's one question. They can't answer that question.
Right. Because if you could answer that, you could stop what that is, which might be much more targeted and wouldn't have the issue of targeting VCP in other tissues.
Right. And so it's interesting though, because what they had done is kind of been like, oh, this protein is the problem in ALS. But really, it's the buildup of the protein because there's another signaling molecule that breaks the exit. And so that's the chain of command. And if you can go back,
Yeah.
So step by step.
So we took it one step back. We need to go another step back.
Yeah.
Okay. That's really interesting. I think that is a really exciting part of medical science. Especially also related, a lot of cancer studies, they're kind of taking it step back. So not just attacking the cancer, but what caused the cancer? What is causing the cancer cells to continue to form? What caused that trigger to happen? Because that's how you can prevent disease before it happens.
Yes.
And that's also how you can treat it better. Right.
Exactly. And
have less side effects, all that kind of stuff.
Yeah. So instead of with a cudgel, right? You're fixed. Oh, okay. It's a scalpel, right? The resolution of our understanding is increasing, which I think is very exciting.
That's awesome.
Yeah. So I like this study because of that. And the last study for the night is basically the question, how do our brains decide what is us? Right? Where you are not your desk. You are not, your hands are on the desk. You are not a part of the desk. Maybe you took hallucinogenics and suddenly that understanding has changed, but our brains are able to determine the edges of ourselves and also allow us to do things like drive cars, use keyboards, write with pens and pencils. So allow us to use tools as if they were part of us.
Oh, interesting.
But still allow our self-identity, our self-understanding to be us. You get in a car and you drive, and you can drive it as if you go, okay, I know where the edges are. I know where I can be, but you are not the car, and you're not the car.
Mm-hmm.
And how does that happen? We have issues with issues of brain health where people have strokes or other diseases that suddenly they decide that the left half of their body is not them any longer. Right? Mm-hmm. Where that is a different person and it's following them everywhere and what's going on, and they're angry at this or their arm or their foot. Suddenly a part of your body you decide is not you any longer. The other side of that is if you've had an amputation.
Yeah, phantom limb. That's the next thing I was going to ask you about.
Yeah. And so then there's phantom limb on top of that, where your body won't let it go, where it thinks it is still owning something that does no longer exist. Yeah. And so at the Karolinska Institute, researchers, they just published in Nature Communications their work into alpha oscillations, which is a very high frequency oscillation that occurs. And they were recording using EEG recordings. They did brain stimulation. They also did computational modeling. They had 106 participants as part of the study. But basically, they attempted to determine how physical, tactile, and other stimuli add up to give you your sense of body ownership. They did play with the rubber hand illusion, which is this mirror test where you have your hand underneath a table, and then on top of it is a rubber hand. It's not your hand, but you look at it and it's in a place that could be almost your hand. And so, yeah, and then a researcher will stab it, or do something terrible to it, make it hurt. And then the person feels the pain even though they were not hurt. And so in this perceptual task, what they were recording were the alpha waves of the participants. And so what they found, participants who were like more likely to go, rubber hands, not mine, and to make a determination, a differentiation, they had more faster, like actually stronger alpha waves in their brain when they were making that determination than individuals who were more likely to go like, that hurt. Oh my gosh, you hurt my hand. And then be surprised that their hand was under a table. So they moved on from these rubber hand experiments, and they were able to determine that there is a part of the brain that is more involved in this than we would have thought. And so what they basically have determined is that there is this fundamental brain process shaping our continuous experience of being embodied, and it could go away at any point in time. The alpha wave frequencies seem to be very important in managing this. They were able to make those individuals, any individual, change their perception of whether or not the rubber hand was theirs by doing electrical stimulation of the brain. So they did external stimulation to different areas to increase alpha wave intensity. And so those individuals who are like, oh my God, my hand was stabbed, they increased the alpha waves and they went, oh no, that's not my hand. And they were able to get the alpha waves to a point to have those individuals who were fooled actually realize the difference and what was going on. So anyway, but there, it seems to be that that they'd like to not just determine the alpha wave frequency, but see how they can use this to shape and contribute to things like fake limbs, so prostheses and other things, so that it could allow people to have a better sense of self for those individuals who maybe have lost limbs and are having problems accepting those body parts as their own. But anyway, your brain's got waves, and it has to do with like the synchronization of high frequency waves in the brain, basically like it's sensory and cognitive, like the networks of the brain coming together to make a determination of what is real and what is not real. This could also influence virtual reality as well. To make virtual reality more real as well.
They're just trying to make the Matrix, Kiki, aren't they? You can't fool me.
I know.
Can I ask a kind of tangential question? What is non-invasive electrical brain stimulation?
Yeah. So the same way that an EEG can be like a cap with multiple sensors that will read brain activity, you can also have conductive paste
electrodes,
that sends electrical activity into the brain. so that people have been using it, this kind of stimulation for muscle stimulation and for
Okay.
brain stimulation for a while.
But so the alpha rhythms are like across the brain enough
yes.
that
Yeah, so
you can just be like, I'm just going to put electrodes on your forehead, and that's going to be good enough to increase or decrease your alpha rhythms.
not just it has to be put in the right place, and it has to be
Right,
the
right,
right
right.
kind of stimulation because of the way that the alpha rhythms are generated. But yes, if you stimulate certain areas of the brain in the right way, you can influence the overall brain frequency.
Yeah, that's really
Yeah.
interesting. The overall brain frequency. Okay.
Yeah.
Because I
Because the
feel like
whole
a
thing is a
lot of
network.
the brain studies that we talk about on the show, a lot of them are like in order to adjust brainwave activity, it's much more invasive.
Mhm.
You have to like crack open the skull and mess with the brain directly, basically.
There's a ton where it has to
yeah.
be electrodes implanted in the brain, but
Yeah.
there have been many, many investigations of, um, I'm not remembering the actual name of the stimulation, but that use electrical stimulation from outside, similar
Mhm.
to like the way that you can use electrical stimulation to deal with tight muscles or those
Mhm.
kinds of. But because of where you place the electrodes and how much stimulation you give it, that people are using it to treat depression. They're treating
Whoa.
anxiety. Like people are doing all sorts of things with this. Like it's
Well,
wild.
this is similar to like in the 70s electroshock therapy, right? Like
But
it was obviously
it,
not it was
it
not a
come out of
scientific,
that. Yes.
right. Yes,
Yeah.
but it was a similar apparatus, I guess, is what you could say, right? It was just
Yeah.
used a lot less. It was it, it was the cudgel you were talking about before, right? It was just like,
Yeah.
yeah.
Yeah. And it's still like people still do just like electroshock to the brain, in serious situations. It's like a reset, right? But
Yeah.
in what we're doing now, people are trying to find ways to uh, adjust the electrical activity within their brain in a way that is beneficial to their behavior.
Mhm.
So if you're somebody who is suffering from, really terrible, depression or anxiety, like you're more likely to be like, okay, I will put electrodes on my head and see if I can change something. And it's not,
Mhm.
and the frequencies and the energy, the power levels they use are not high enough to do any damage to your skin. And people suggest that there have been benefits. It's not everybody, and this is not. I'm not saying go out and like, put electrodes to your head.
Fry
This
your
is
brain.
definitely the kind of thing that is still experimental. It needs to be done with the advice and oversight of a doctor. But people are using brain stimulation to help them with focus, with other issues related to mental health. I find it fascinating because it is the same it's the opposite of the EEG, where the EEG has the electrodes all over your head to kind of get a global picture of electrical activity. Whereas if you thought of the location of different electrodes for stimulating activity, you could actually potentially kind of pinpoint certain regions of your brain that instead of doing a global reset, you just change the local situation. And by changing the local situation, eventually you change the global because it's all networked.
Mhm. Yeah, and you're changing kind of practiced pathways and all that kind of stuff.
Yes.
Absolutely.
Right. And so by the electrochemical pathways of the brain, by maybe stimulating electrically certain neural pathways, maybe there will be growth. Maybe you'll have more synapses. Maybe you'll have the impact that we need to get to that, non-depressive place or
Mhm.
wherever it is that you want to be. But years ago, I was like, what? This is wackadoodle. But it
Yeah.
is, the evidence is fascinating. And for some people, it really works. I think it's still a cudgel, but it's a smaller cudgel.
Yeah. No, absolutely.
But,
It's a softer cudgel too, I think.
yeah.
Nice. Well, I
Yeah.
can't
So
wait to hear
anyway,
more about this. Yeah.
yeah, your body is yours because of your brain and the synchronization of brain waves that
I'm going to think
allows
about this
that to
on my
happen.
commute tomorrow.
Right?
My alpha
I am
brain
not my
waves
car.
are telling me what the size and shape of my car is, but that I am not my car. Absolutely. Love that.
Yeah. I mean, seriously, why are tools, but we do not, and we use them as if they're extensions of our body, but they are not us. Right? I think it's fascinating. And I wonder things like race car drivers or people who do use things like cars, like whatever, at an extreme level of ability. Do they feel like they're their car? Like, do they have actually lower alpha waves because there's no barrier between them and the car?
Yeah.
I think
Or
that's an
even
interesting
like,
question.
could highway hypnosis be explained by this? Right? Where
Mhm.
you just kind of zone out and you are your car and it's been
Right?
20 miles. Absolutely.
Yeah. So many questions. PhD research ideas for anybody out there who wants to go study them. Blair, have we done it?
We've done it.
We've done it. We made it to the end of the show. Thank you, everybody, for sticking
Yeah.
with us and joining us for
It was
this
a fun one.
conversation tonight. Yeah. I appreciate it. I honestly, it's been a rough week. And so coming here and having a good conversation and just enjoying being curious and digging into stuff like this, it's good for me. So I hope it was good for you.
It's great to be reminded that even when there's really scary or upsetting or strange things happening out in the world, there are still people who are going into the lab every day. They're putting on their lab coat, they're grabbing their pipette, and they are making our future better.
Yeah.
Through knowledge, through experimentation, through improvements to human health or technology. It's awesome.
So many questions. Let's find the answers together. Shout outs to all of you in the chat room. Thank you for joining us tonight. Gord, Arenlor, thank you for all the work that you do, making sure that our chat rooms are good places to be. But really, it's all of you. Come on, everyone. It's you making it good places to be. You are the chat. Chat. Vada, thank you for your help with social media and show notes. Identity 4, thank you for recording the show. And Rachel, thank you so much for all your work editing the show. I just appreciate all the work that people do to make this show possible, especially our Patreon sponsors. So thank you to Aaron Anathema, Adam Mishkan, Alan Viola, Ali Coffin, Andrew Swanson, Artem, Arthur Kepler, Bob Calder, Bob Coles, Brendan Minish, Brian Carrington, Chris Wozniak, Christopher Dreyer, Christopher Rappin, Craig Landon, Craig Potts, Daryl Myshak, Dave Wilkinson, David E. Youngblood, Don Mundus, Donathan Styles, a.k.a. Don Stylo, E.O., Eden Mundell, Eric Knapp, Flying Out, Fredis 104, G. Burton Lattimore, George Chorus, Greg Briggs, Jack, Jason Olds, John Atwood, John McKee, John Ratnaswamy, Johnny Gridley, Ken Hayes, Kent Northcote, Kevin Perchan, Kevin Reardon, Kurt Larson, Lon Makes, Lauren Gifford, Mary Gertz, Marjorie, Mark Hessenflow, Mark Jenkins, Noodles, Patrick Pecoraro, Paul, Baldy Disney, Paul Ronovich, Philip Shane, Pierre Velazarb, Richard Badge, Robert Norland, Robert Farley, Rodney Lewis, Rudy Garcia, Remy Day, Sean Clare Slab, Shoe Brew, Stephen Alberon, Steve Leisman, a.k.a. Zima, Sue Doster, Teresa Smith, Tony Steele, and Vagar Shefstad. Thank you for your support of TWIS on Patreon. And if you would like to support TWIS, head over to twis.org and click on that Patreon link. You'll follow the instructions. I know you will. You're good at that. On next week's show.
We back on Wednesday at 8 p.m. Pacific time, broadcasting live from our Twitch, YouTube, and Facebook channels.
Oh, yeah. Want to listen to us as a podcast? Just search for This Week in Science wherever podcasts are found, wherever you like to find podcasts. And if you enjoyed the show, make sure to get your friends to subscribe too. Share TWIS. Whoop.
For more information on anything you've heard here today, show notes and links to our stories will be available on our website. That's at www.twis.org. You can also sign up for a newsletter there.
And we love your feedback. If there is a topic you would like us to cover, address, or suggestion for an interview, let us know on one of our social media accounts or send us an email. Make sure you put TWIS in the subject line so your email doesn't get spam filtered into a malfunctioning bear identification system.
Say, this isn't a bear, this is an email.
No, bears are emails too.
We look forward to discussing science with you again next week. And if you've learned anything from the show, remember.
It's all in here.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week